Today, I'll introduce zombie idea number 4, data don't lie. Zombie ideas are the ideas that refuse to die despite evidence to the contrary. In my previous videos, I introduced zombie idea number 1, leaders are saviors. Zombie idea number 2, leaders are a special breed of people. And zombie idea number 3, a team must have a leader. The zombie idea number 4 I'll introduce today, data don't lie, is another pervasive zombie idea in leadership. This is the belief that data are infallible and immune to misinterpretation or misuse. Let's dissect this a little bit. At first glance, data appear objective, factual, and trustworthy. In our data-driven society, there is immense pressure to quantify success and demonstrate progress through numbers. They offer an allure of simplicity. Data provide a seemingly straightforward way to make complex decisions. Data provide a sense of certainty and control in an uncertain world. But how could data possibly mislead? Well, the truth is, data can and often do mislead depending on how they are collected, analyzed, and presented. Just like any tool, data are only as reliable as the methods and intentions behind its use. As Mark Twain famously said, there are 3 kinds of lies: damned lies, and statistics. This highlights how data, when manipulated or taken out of context, can be used to support almost any argument, often obscuring the true picture and leading to misguided decisions. For example, consider how data are often used in performance metrics. An organization may boast about its impressive growth. However, after examining the data, you may find that the growth was achieved by cutting essential costs, which left the employees overworked and with low morale. The data point of growth in performance metrics in isolation doesn't tell the whole story, it lacks context. Similarly, in educational settings, standardized test scores are frequently used to measure student achievement and school performance. However, those scores can be influenced by numerous factors outside the school's control, such as socioeconomic status or access to resources. When school leaders at the district and school levels boast about the increase in graduation rates, they may be masking underlying issues such as grade inflation, lowered academic standards, or choosing an easy test. This narrow focus on a single data point can create a misleading narrative of success, ignoring the well-rounded development of students and the true quality of education provided. This is where Goodhart's law comes into play. When a measure becomes a target, it ceases to be a good measure. What does it mean? Once the metrics are known, people and organizations may begin to game the system to meet those metrics, often to the detriment of underlying goals they were meant to serve. In the pursuit of improving specific metrics, broader goals can be overlooked. In education, if standardized test scores become the primary measure of success, teachers teach to the test, focusing only on test-related content and neglecting broader educational goals such as critical thinking and creativity. In business, if sales numbers are the primary metric, employees may push unnecessary products onto customers and engage in unethical practices to boost short-term sales, ultimately undermining customer trust and long-term profitability. In finance, if performance bonuses are tied to quarterly earnings, executives may manipulate financial reports or take excessive risks to meet targets, potentially leading to financial instability or scandals. Crime statistics can be particularly susceptible to manipulation. A city administration may boast about a decrease in crime rates, but this could be achieved by reclassifying certain crimes to less severe categories or by underreporting crimes. This manipulation creates an illusion of society and effectiveness in law enforcement, while the actual public safety situation may remain unchanged or even deteriorate. Data can also be manipulated, intentionally or unintentionally, through selective presentation or biased analysis. We can emphasize certain data points while ignoring others that may present a more nuanced or contradictory picture. For example, an organization may showcase a significant increase in performance metrics, conveniently admitting that the boost was a one-time event rather than sustainable growth. By presenting data selectively, the organization creates a misleading impression of consistent success, potentially influencing stakeholders' decisions based on incomplete information. Experts and researchers can also engage in data dredging or p-hacking to manipulate data in order to find patterns that support a desired conclusion. In statistical terms, P stands for the p-value, which measures the probability that the observed data would occur by chance if there were no real effect. Typically, a p-value less than 0.05 is considered statistically significant. However, by running multiple statistical tests, we can increase the likelihood of finding at least one significant result purely by chance, regardless of whether it is meaningful or representative. For example, a pharmaceutical company may conduct numerous clinical trials on a new drug, disregarding those that show no effect or negative outcomes, and only publishing the few that demonstrate positive results. This selective reporting can give the false impression that the drug is highly effective despite the potential risk or ineffectiveness for the broader population. In administration and management, consider a scenario where an organization wants to prove that a new employee training program significantly improves productivity. The organization conducts several small-scale studies, each with different methods and sample sizes. Many of those studies show no improvement or even negative effects, but a few studies produce statistically significant results purely by chance. The organization then selectively reports those positive results, ignoring the majority of studies that found no benefit. This creates a misleading narrative that the training program is universally successful, prompting widespread implementation. However, the actual effectiveness of a program may be marginal or non-existent. Implementing such a program can lead to wasted resources and unfulfilled expectations. Another common approach to manipulating data is biased methods, where researchers or experts consciously or subconsciously collect and interpret data in ways that confirm their existing beliefs or hypotheses. At the data collection stage, administrators can frame survey questions in a certain way to get the data they want. For example, a school district seeking to justify budget cuts might design survey questions in a way that emphasizes financial strain and minimizes the importance of educational programs that are at risk. Questions may be framed to lead respondents towards agreeing with the necessity of budget cuts, such as, do you agree that in times of financial hardship, it is important to make budget adjustments, rather than a more neutral question like, which areas of budget do you believe should be prioritized? Similarly, in organizational settings, an organization wanting to show high employee satisfaction may craft questions that elicit positive responses. Instead of asking, how satisfied are you with your job? They may ask, how satisfied are you with the company's efforts to provide a positive work environment? This subtle shift in wording can lead employees to focus on positive aspects and different wording can skew the overall job satisfaction rating upward. In political polling, biased methods can manifest in different ways. A campaign may conduct a poll where the questions are framed to favor their candidate. For example, asking, "Do you approve of the candidate's efforts to improve healthcare?" instead of, "What's your opinion on the candidate's performance?" Different wordings can lead to more favorable responses. By selectively polling areas where the candidate is popular, the results may naturally skew in their favor, creating an illusion of broader support. Environmental studies can also fall prey to biased methods. A company that benefits from relaxed environmental regulations may sponsor research that frame questions to downplay environmental risk. For example, instead of asking, "How concerned are you about pollution in your area?" they might ask, "Do you believe that the local industries are taking adequate measures to control pollution?" This can lead to responses that seem to indicate public approval of the industry's efforts despite underlying concerns. At the data interpretation stage, our pre-existing beliefs and preferences can also cloud our interpretation of results of data analysis. For example, a political campaign may analyze polling data to highlight trends that favor their candidate while downplaying or ignoring data that suggests weakness or declining support. This biased interpretation not only misleads the public, but also potentially skews campaign strategies and reduces allocation based on an incomplete understanding of voter behavior. In an article titled, "All the Best Polls Agree with Me: Bias in Evaluations of Political Polling," published in Political Behavior in 2020, the authors explored the phenomenon of motivated reasoning in the context of political polling. They conducted 2 experimental studies. One focused on candidate evaluations during the 2016 U.S. election, and another study on the policy issue. Their findings indicate that respondents perceived polls as more credible when the majority opinion aligned with their own views. This suggests that instead of objectively evaluating the methodology or transparency of the polls, such as the sampling methods, for example, random sampling versus convenience sampling, the track record of the polling vendor, for example, their history of accurate predictions and reliability, or the clarity in reporting data, for example, providing detailed breakdowns of demographics, margin of error, and question wording. People tend to judge poll credibility based on whether the results align with their pre-existing beliefs. This biased evaluation process overlooks critical aspects that can significantly influence the accuracy and reliability of poll results. A poll using random sampling with a well-documented methodology and transparent reporting is inherently more credible than one using convenience sampling with vague or incomplete data closure. However, if the latter confirms our opinions, it may be perceived as more trustworthy despite its methodological flaws. The same study also found evidence of attitude polarization after viewing polling results, indicating that exposure to poll data can reinforce and intensify existing opinions. For example, if an individual who supports a particular candidate sees a poll showing that their candidate is leading, their support for the candidate may become even stronger. On the other hand, if they see a poll where their candidate is trailing, they may dismiss the poll as biased or inaccurate, further entrenching their original beliefs. This bias in evaluating political polls highlights significant challenges in ensuring that the polling data effectively informs decision-making. Instead of objectively analyzing poll results based on methodological rigor, such as the representativeness of the sample, the precision of the question, and the transparency in data reporting, our subjective perceptions heavily influence our interpretation of the data. This subjective bias can skew the perceived credibility of polls, and we make decisions based more on confirmation bias than on strong empirical evidence. The integrity of data and its analysis and interpretation are critical for informed decisions. To combat this zombie idea of data don't lie, leaders, administrators, and managers must recognize the potential for manipulation. Leaders may not need to be scientists, but they must have a basic understanding of scientific research methods. This means leaders should understand proper sampling techniques, the importance of control groups, the potential for bias in data collection, statistical tests and measures, and how qualitative data can be skewed by subjective interpretation, and recognize the limitations of both qualitative and quantitative data. This foundational knowledge allows us to ask the right questions, identify potential red flags, and ensure that the data being used to inform decisions are reliable and valid. So the next time you hear someone say, data don't lie, remember to critically evaluate how the data are collected, analyzed, and interpreted. You can ask questions such as, how were the data collected? What survey or interview questions were asked? Who was included in the sample? How was the sample selected? Are there any potential biases in the interpretation? Data can be a powerful tool, but they are not infallible. They are subjected to human biases, limitations, misinterpretations, and misuse. By acknowledging this, we can better navigate the complexities of leadership and make more informed and balanced decisions. Let's stay vigilant and ensure that the zombie idea of data don't lie doesn't lead us astray.